This topic deals with multi-period cash flow problems that can be formulated as linear programming problems. So we're going to talk about a general formulation for some of these problems using an example. So what are multi-period cash flow problems? These are problems where current decisions may directly affect future decisions. So for example, let's say that you made a decision in a manufacturing plant to have a minimum inventory level at the beginning of period 2 of 200 units. Well, that decision that is made at that point is going to probably have an effect. It's going to affect a performance measure of interest, such as total cost in the system and so forth. So that initial decision, that current decision, is going to have an effect on future decisions, okay, the future performance measures. Many financial decisions involve multiple time periods because the amount of money that is invested now affects money that is available later. So these particular multi-period cash flow problems, are good for those financial decisions. And linear programming, as we will see, can help us to find good solutions for these types of problems. So let's go through an example. A top manager of a corporation, Panera Bread restaurant chain, has decided to build a new location in Viera, Florida. The manager wants to establish a construction fund, or call it a sinking fund, to pay for this new facility. So he wants to be able to invest in the most efficient way so that he can pay the total cost of the facility. The construction cost is expected to take 6 months and at a total cost of $800,000. So he wants to be able to invest in order to repay that $800,000 cost. The contract with the construction company requires payments of $250,000 at the end of the second and fourth months, and a final payment of $300,000 at the end of the sixth month. So the payments are divided into 3 sections. The manager can use the following 4 investment strategies or opportunities to establish the construction fund. So there's 4 possible investment opportunities, and they're available in different periods of time. So for example, the manager can invest in investment A in the beginning of periods 1, 2, 3, 4, 5, 6. And for example, the manager can invest in investment opportunity D only in month number 1, because the maturity of this investment is 6 months and the total project duration is 6 months. Okay, and the yield for each of the funds is 1.8% for investment A, 3.5 for investment B, 5.8 for investment C, and 11 for investment D. So what this table shows is that investment A will be available at the beginning of each of the 6 months, and investment B, it will be available at months 1, 3, and 5. Investment C can be available at months 1 and 4, and D at 1. Okay? Manager needs to determine an investment plan to meet the required schedule of payments while placing the least amount of money up front in the construction fund. So he wants to determine a plan that's going to allow him to repay these 3 different payments of $250,000 at the end of the second and fourth months, and this final payment of $300,000, which will constitute the total cost of the project. And at the same time, he wants to place the least amount of money up front. Okay, so he wants to be able to minimize that amount of money that is placed in month number 1. So eventually, whatever is left, this money is going to be reinvested. So this is the problem statement. I would like to highlight the important parts of the problem to help me develop a formulation for it. Okay, so hopefully this makes it easier for you when you're reading this. So we want to build a new location, establish a construction fund to pay for this facility. It's going to take 6 months at a total cost of $800,000. Requires payments of $250,000 in 2 of the months and $300,000 at the end in 6 months. There are 4 investment opportunities, and your objective again is to determine an investment plan to meet the required schedule of payments while placing the least amount of money up front. Okay, so pretty much this is a summary of the problem statement. Again, this is describing the problem statement, and it tells you the different investment opportunities and when are they available, or what months do they become available, the months of maturity, and their yield of return when they mature, okay, towards the end of the maturity period. So what is the objective in this problem? The objective here is to minimize total amount of money to pay upfront. So we need to decide what are the decision variables in this problem in order to set up a formulation that's going to help us achieve this objective. Okay, so what are the variables in this problem? We have a series of variables. Okay, so we're going to say A sub I equals the amount in thousands, to make it easier on us, placed in investment A at the beginning of each of the months. So, okay, month I, and I goes from 1 to 6, because you can invest in each of these periods in investment A. Okay, now investment B, you can only invest in periods 1, 3, and 5. So B sub I is going to be the amount in thousands placed in investment B in the beginning of month I. Okay, so we're restricting I to be 1, 3, or 5. C again is just going to be the same thing, amount of money that can be invested in investment C at the beginning of months 1 to 4, because based on the table that we saw before, those are the only times that we can invest in C. And D sub I is the amount in thousands placed in investment D at the beginning of month I. In this case, I is only 1. Okay, so this can just be D1, and it'll be okay. Okay, so these are our different decision variables. So we have 6 decision variables associated with investment A. We have 3 decision variables associated with investment B, 2 decision variables associated with investment C, and 1 associated with investment D. Okay, so these are the total set of decision variables in our problem. Okay, it's important to understand what are the cash inflow and outflows at the beginning of each month in order to provide a formulation for this problem. Okay, so hopefully this will make it more clear for you. Okay, so this table is showing possible cash flows. Okay, so these are the possible investments where we have investment A, B, C, and D. The subscript represent the month where you can invest in. So these represent the amount of money that can be invested in investment A during month 1. So this A2 is the amount of money that can be invested in month 2 for investment A, and so forth. Okay, as we can see, these are the required payments. Okay, so 250,000 must be repaid at the end of period 2. So it's pretty much the same thing as saying that it must be repaid at the beginning of period 3. So that's why you see it here. Again, 250 must be repaid at the end of period 4, which is the same thing as saying that it must be repaid at the beginning of period 5, and then 300,000 towards the end. Okay. Every time when you see a -1 here, it means that there's a potential opportunity, or you're allowed to invest in that particular investment for that particular month. Okay, so if you recall, investment A has a maturity period of 1 month. So you can invest in investment A in month 1, in month 2, that's why you see A2 here, that's a -1. In month 3, that's why A3 here is a -1. And in month 4, A1 is a A4 is a -1, and so forth. Okay, so investment A has a maturity period of 1 month. Okay, so after 1 month, if you invest in investment A in month 1, you're going to have a maturity yield, or you're going to receive 1.018 of the amount that was invested in A1. Okay, so that's what this is saying in here. Okay, so at the beginning of month number 2, you're going to have a cash inflow of 1.018 times A1. Okay, whatever amount was invested in A1. If you decide to invest, or there's an opportunity here to make an investment in investment B in period 1. Now, investment B has a maturity period of 2 months. So if you invest here, you're going to receive a yield of 1.035 times B1 at the beginning of month 3. Okay, investment C has a maturity period of 3 months. So you have an opportunity to invest here in month number 1, and then you'll receive a yield, a return of 1.058 times C1 in the beginning of month 4, and so forth. Okay, so if you invest in investment D, for example, the only opportunity that you have to invest in investment D is in month number 1, okay, because it has a maturity period of 6 months. Okay, so if you invest here in month number 1, you're gonna receive a yield of 1.11, because the yield of return of anything that's invested in investment D is 11%. Okay, so it's going to be 1.11 times D1, and so forth. So this information helps us to define a series of cash flow equations that are very critical to formulate constraints for this problem. Okay? Hopefully we'll see it even better in the next few slides. So what is the objective function? So let's first start with the objective. The objective per the problem statement is to place the least amount of money up front in order to meet a required schedule of payments. Okay, so we want to minimize total cash invested in month number 1. Okay, that's the money, that's the upfront money. Okay, so minimize A1 plus B1 plus C1 plus D1. Okay, notice a few things. Okay, so your decision points here are the beginning of each month. Your objective is how much money to invest up front, and the invested money in month 1 will be reinvested. Okay, so we'll take care of that again through a series of cash flow equations in the constraints. So what are the constraints in this particular type of LP problem? Okay, basically we have something called cash flow constraints for each month. Okay? Basically this is saying that assuming that the company invests the amounts represented by A1, B1, C1, and D1, which is the upfront amount, the question is how much money will be available to reinvest or make the required payments at the beginning of months 2 through 7. So what you need to realize is that the money paid up front is going to be reinvested. Okay, we want to minimize that upfront amount and also make sure that they meet the required payments at the beginning of months 2 through 7, whenever there's a required payment. Okay, and to answer this question, we need to generate a set of cash flow constraints for this problem. So let's discuss how do we set up those cash flow constraints. Okay, so let's look at the cash flow constraint for month number 2. Okay, the idea here is to understand that cash in is equal to cash out. Okay, so the amount of money that you receive at the beginning of each period is you want to be able to reinvest it. Okay, so that's what that means. Okay, so for example, the cash in for month number 2, which is in here, is going to be 1.018 times whatever money was placed in investment A during month 1. Okay, because this is the only opportunity here that you have to receive any money. Okay, if you invest in investment B during period number 1, it takes 2 months to mature, so you're not going to receive anything at that point, so you have to wait until the beginning of month 3. Okay, so the only opportunity here is to receive any money in the beginning of month number 2 is to invest in A1. Okay, so whatever amount was invested in A1, just multiply 1.018 A1, and that's the amount of money that's going to represent the money that you can reinvest in the beginning of month number 2. Okay, so that's what we see in there. And cash out, it's going to be any new investment opportunity at the beginning of month number 2. Again, we can see that the only opportunity to invest at the beginning of month number 2 is A2. Okay, because it's represented by that -1 number, and that's what we see in there. So any payment that is required at the beginning of month number 2, in this case is 0. Okay, so that's going to be cash out. So you don't have to pay anything in the beginning of month number 2. Okay, that'll be something to deal here in the beginning of month number 3. Okay, so following this formula, the cash flow for month number 2 is equal cash in is equals to cash out. So it's going to be 1.018 A1 is equal to A2 plus 0, because you don't owe anything. You don't need to repay anything in the beginning of month number 2. So this becomes your constraint, okay, your cash flow constraint for month number 2. Okay, and what this is saying is that you can reinvest. You will reinvest everything that you receive during the beginning of month number 1, which in this case is going to be only 1.018 times A1. Okay, this becomes the cash flow constraint for month number 2. The cash flow constraint for month number 3, again, we're following that formula where cash in equals cash out. In other words, whatever cash in we receive in the beginning of month number 3 is going to equal to the cash out, to the amount that we want to reinvest. Okay, cash in month number 3 will be 1.035 times whatever amount was placed here, investment B during month 1, and 1.018 times any amount that was placed in investment A during month number 2. Okay, so that the cash in for this month number 3 is going to be equal to 1.035 times B1 plus 1.018 times A2. Okay, now the cash out is going to be equal to any new investment opportunity at the beginning of month number 3. In here there are 2 investment opportunities, so it's going to be A3 plus B3, and any payment that is required at the beginning of month number 3, in this case it's 250, is specifying here. Okay, so our cash out is going to be equal to A3 plus B3 plus 250. Okay, this is our cash out for this problem. We say cash in is equal to cash out, and we want to have a right hand side that is a constant in this problem to set up the constraint, and this becomes our constraint. 1.035 B1 plus 1.018 A2 minus A3 minus B3 is equal to 250. So this is going to make sure that we have whatever cash we receive in month number 3, in the beginning of month number 3, we're going to reinvest. Okay, so this becomes the cash flow for constraint number 3. And if you use the same procedure, you can calculate the cash flows for each of the rest of the constraints. Okay, so notice that at the beginning of month number, at the end of month number 2, we're going to repay 250, which is the same thing as saying at the beginning of month number 3, same thing as in the end of month number 4, 250, and towards the end, this is pretty much saying that that's on the beginning of month number 6. At the end of month number 6, we're going to repay 300,000. And of course, we have our non-negativity constraints. Okay? So these are all the cash flow constraints for this problem. The final formulation is this one. We have our decision variables. We have our objective function, which is a minimization problem with the emission of the upfront money. And we have our series of cash flow constraints for all of them. Okay? And we clearly define here what the decision variables are. Okay, so this is the final formulation for this problem. In a problem such as this one, where you're investing in different opportunities, it may be important to understand how can you consider risk. Okay, so let's just go through this example. This is just in addition to the previous example to see how one way that we can sort of include risk in this problem. So assume that the manager has assigned the following risk ratings to each investment on a scale from 1 to 10, where a 10 is the maximum risk, very risky investment. Okay, so investment A has a risk rating of 1, B has a risk rating of 3, C is the riskiest one, has a risk rating of 8, and D has a risk rating of 6. Okay, so the manager wants the weighted average risk not to exceed 5. Okay, so you cannot be risk-free, and arbitrarily this was set up by the manager. The weighted average risk cannot exceed 5. How would you modify the LP formulation to consider this risk? Okay, so manager wants the weighted average risk not to exceed 5, and we have 4 different investment opportunities and risk rating for each of them. Okay? What we need to realize is that risk continues or begins as soon as we invest money and ends only when we receive a payoff from that investment. So, for example, if we invest here in B1, for example, there's a risk associated with the investment that was done at the beginning of month number 1, and it's going to end only at the beginning of month number 3. So there's a risk associated with that investment B1 also here in month number 2. Okay, we already invested the money here in month number 1. There's still a risk in here associated with that investment, and we're only going to be risk-free from that investment B1 at the beginning of month number 3. Okay, so knowing that, for month number 1, what we want to have is a weighted average that is less than or equal to 5. Okay, so what are the risk opportunities in here? Well, we have an opportunity in month number 1 to invest in these 4 possible options. Okay, so A1, B1, C1, and D1. Okay, so 1A1 plus 3B1 plus AC1 plus 6D1, and I'm using here as a coefficient this risk ratings associated with each of the possible investment opportunities. That is going to give us the total risk level, if you will, okay, associated with those investments. If you divide by the total amount that was invested, that's going to give you a weighted average. Okay, so the weighted average here must be less than or equal to 5. Okay, so let's look at month number 2. Okay. In month number 2, if we can see here, we have an opportunity to invest here in A2. If we invest it in B1, C1, or D1, we still have a risk associated with those investments. In the beginning of month number 2, there's no risk associated with investments in A1, so there's no risk associated with it. Okay, so that's why our total risk level, if you will, is going to be associated with B1, C1, D1, and A2. And that's why those are the variables that we see here. Okay, B1, C1, D1, and A2. And of course, we have the coefficients to represent different risk ratings. Okay, so if you divide that if you divide it by A2 plus B1 plus C1 plus D1, which is the total amount, it gives you a weighted average. Okay, and that has to be less than or equal to 5. And you do the same thing for the rest of the months. Okay, so what we're looking at are opportunities where we can see risk. Okay, so for month number 3, there's no risk associated with any investment that you made in B1, but there's a risk associated with C1, with D1, nothing with A2, but yes with A3 and B3. Okay, so that's why for month number 3, you're going to see A3, B3, C1, and D1. Okay, A3, B3, C1, and D1. Okay, and by doing this is one way to include risk in your formulation and consider risk when you're making decisions of this sort. So the final formulation, when we solve for them, again, all we're doing is just multiplying denominators times the right-hand side value and just bringing it to the left-hand side from the previous slides. These are the constraints, risk constraints that you would add to this problem to make sure that you have a weighted average that is less than or equal to 5.